Hey guys, we're going to do another Chapter 4, Section 3 video. So if you're using the same book as we are in class, that's the section we are in. In this video, we're going to focus on this essential question. I'm noticing class some people struggling with this, so it's a good opportunity for a video lesson. What is the difference between an intercept and intersect? Now, at first glance, this might just look like a spelling difference, but it's a little bit more than that. So the key words here are intercept with a C and intersect with an S. So intercept and intersect, what are the differences between that? And what I'm going to do is leave a little space right here, and at the end of the video we're going to come back to this little extra space and we're going to write a couple of notes. So if I was you, leave a little bit of room underneath here, and we'll come back to it at the very, very end. But here's what we're going to do. We're going to try a problem, an example. And what I'm going to write is I'm just going to put example in my graph paper here. And we're going to analyze a system of two lines. So we have two linear lines in a system, and here is our system. And we call anytime we have more than one line on a graph, we call it a system. So here's the system we're going to be dealing with. One of our lines is going to be y equals 3x plus 4. That's one of them. And then our other line is in point slope form. It is y plus 17 equals 3 parentheses x plus 4. And what I want to do is I kind of want to analyze this system. I'm kind of curious if these lines, where do they intersect? Where do they cross? And so we're going to figure that out. That's going to be our game plan. Now this one's going to be easy for me to graph. I know that the y-intercept is 4 and 3x tells me the slope is 3. So when I see this one right away, I'm like, okay, y equals mx plus b. I see the m and I see the b. That stands out very clearly to me. What do I see in the other one? Well, I see y plus y1 equals m times x plus x1. I see point slope. So I see a slope of 3 and I see a coordinate point at this 4 and 17, although it's actually y minus y1. So that's kind of an indicator that this must be a minus minus. So here's what I'm going to do. I am going to set up a graph, but before I do, I'm going to rearrange this point slope one and make it a little more feasible to work with. So let's go off to the side over here where we have some room. And let's take y plus 17 equals 3 parentheses x plus 4. Let's put a line down it and change it into y equals mx plus b. Let's make it usable. So I'm going to distribute the 3 in to my parentheses, 3 times x and 3 times 4. I'm going to have y plus 17 equals 3x plus 3 times 4 is 12. And then I'm going to take this 17 away from both sides to get rid of it, and I'm going to get y equals 3x plus 12 minus 17. That's going to be minus 5. And then there is my equation. Okay, cool. I feel a little bit better about graphing now. Here's what I'm noticing. These are my two lines that I'm graphing. What do we see about these two lines? Well, the slope is 3 and the slope is 3. I see same slopes. So what do I know about the lines if the slopes are the same? They're parallel. They must be going at the same rate of change. So they're never going to intersect. But let's actually look at that a little bit closer on the graph and see what that looks like. So down below down here, I'm going to grab a ruler and set up an XY axis. And I'm going to make it pretty big. I want a lot of room to work today. So let's zoom this camera out even a little bit so we can see a little bit more. Let's draw a nice big XY axis. So let's see, here's my Y axis. Give myself lots of room to work here. Pretty big. And then I'm going to draw an X axis somewhere like up here maybe. Maybe a little farther down. I'm just kind of estimating on the size here. There we go. There's my X axis. I'll label it X. We're going to get some scale numbers on there. So definitely let's set up the scale. So let's see here. 1, 2, 3, 4, 5. I'll go back -1, -2, -3, -4, -5. Same thing going up and down. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, getting a lot of points on here. So let's just label this. Here we go. We've done a lot of graphing, so we're getting pretty used to setting up scale numbers and labels now. It's becoming kind of second nature. All right, there we go. There's our graph. Okay, so what are we graphing? That is the key thing here. What is going on this graph? Well, two lines are going on this graph. The first line is the one that was up above here, y equals 3x plus 4. So why don't we do that one first? That seems pretty easy. So y equals 3x plus 4. Well, plus 4 means we start at 4 as our y-intercept. And 3x means we have a slope of 3, so we're counting up 3. 1, 2, 3. And then we got to go over 1. And then I'm already kind of at the top of my graph here. 1, 2, 3 over 1. I'm kind of out of space. So if you want to reverse that process, you can go down 3, 1, 2, 3, and back 1. You can kind of reverse the order. Down 3, 1, 2, 3, back 1. Down 3, 1, 2, 3, back 1. And you really only have to do this a few times because you're going to get your points and you're going to have your line pretty quickly here. So let's draw our line. There we go. Just like that. And what I'm going to do, since we're making a system, is I'm going to be sure to label my line. So maybe down by this arrow, I'm going to write, this is the y equals 3x plus 4 line, just to make sure I have that label. Now let's do our other line that needs to go on the graph, and that's this one that we just rearranged, y equals 3x minus 5. So we're now going to start down here at minus 5, right there. And again, 3x means we have a 3 slope, so we're going to go 1, 2, 3 over 1, 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 1, 2, 3 over 1. Okay, that's probably enough points. I could stop. So I'm going to grab my ruler again. And just like we expected this to happen, this is looking like parallel lines. If it didn't look like parallel lines, I would be pretty concerned, but those look pretty parallel to me. Now, instead of writing y equals 3x minus 5 down here by the arrow, I'm going to write what the original problem was. And the original problem was the point slope form. Y plus 17 equals 3 times x plus 4. So that's what I'm putting down by the arrow. Y plus 17 equals 3 times x plus 4. That's going to be my appropriate label. Now, speaking of labels, what else can I add to this graph? Well, we definitely got parallel lines, so they don't cross each other. But we do have some things we can add on here, like we have our y-intercepts. So here at 4 is where one of our lines crosses. I'm going to label that the y-intercept. It intercepts the y-axis. Notice how I'm spelling it, intercept with a C. It's not intersect. It's not the y-intersect. It's intercept because it's intercepting the y-axis. Here's the one for the other line right here. At -5, that's the y-intercept. Y-intercept. What I was looking for is where do these lines cross each other, and they don't cross. So because they are parallel, there is no point of intersect. So we're going to write underneath this parallel, no point of intersect. Intersect. So a point of intersection is when two lines cross each other, and that's not happening in this graph. Intercepts are where it intercepts the y or the x-axis. We could have labeled the x-intercepts as well, but I kind of just focused on the y-intercepts. I'm also going to put one more thing on my graph. I'm going to show the slope with some growth triangles. I want to show that the slopes matched each other. So how about this one right here? This looks like a good spot for a growth triangle. I'm going to grab a pencil if I have a sharp, do I have a good pencil over here? Yeah, this will work. I'm going to shade this in and label that growth triangle as up 3 and over 1. And I'm going to show that it matches over here identically. If I made a triangle, same thing. If I shaded it in, you can see that same slope, no point of intersect, 3 and 1, matching growth triangles. So there's no point of intersect, that's for sure, and we've got the same slope. And we have a pretty nice looking graph actually. So we're going to do one more example for this video. And we're going to look at ones that hopefully do intersect. So our next example, which I'm going to put right here, is we're going to graph one more system. And for this system, which I'm going to write system, we're going to put two lines on the graph that look a little bit different. The first one is going to be y equals negative 2x plus 4. The second one is going to be y equals 3x minus 5. 3x, oh, it wasn't 3x minus 5 our last line. Why don't we change it to 3x minus 6, just so it's slightly different. That's my 6. Okay, we're going to put these on a graph. Now, right away, I already know that these lines are not parallel because I'm looking at the slopes and I'm like, well, they don't match. I can see the mx plus b. So what I'm going to do is just show that visually. And I'm going to put a little note over here to kind of as an observation. So observation, what do I see? Because if I was on a test, I'd really want to prove that I understand this problem. My observation would be the slopes of these lines are not equal. The slopes of these two lines are not equal. They're not equal. One of them's negative 2, one of them's 3. So the slopes of these two lines are not equal. Therefore, start another sentence here. Therefore, these lines must cross. But I'm not going to say must cross. That's not very mathematical. I'm going to say, therefore, these lines must intersect. Intersect. They must. They've got to cross each other. Although crossing is totally fine description, I'm going to use the word intersect because it's a little bit more mathematical, like I said. So based on the slopes, I just know without seeing the graph, that must be true. I feel very for sure about that. Now here's my graphing evidence. We're going to set up our xy axis over here. I better make sure I can get all the way down to negative 6. So make it fairly long. Let's see. I'll go right here. That can be my y-axis. And then somewhere in the middle here, put an x-axis, maybe right about there. Sure. And we'll set up our scale. So quickly throw on some numbers. Like I said, we've done this so much, we're getting very quick and efficient at setting up a scale. And if my number's really big, I might scale it by 2 and count by 2s or 5s or something, but it's not. The numbers aren't very big. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Same thing going up, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. Better go to negative 6, get a little more space in there. Okay, so there's our graph. If I went fast, pause the video, make sure yours looks nice. But here is what I'm going to do. I'm going to plot both lines. So the first one is negative 2x plus 4. So we're going to start at 4. That's our y-intercept. And we're going to go with a negative 2 slope, so we must be going down 2. So we're going to go down 2, but still over 1. Down 2, but over 1. Down 2. We always work to the right. Down 2 over 1. I'm going to keep doing that. Down 2 over 1. Down 2 over 1. If I want to go backwards, I'd have to go up 2, back 1. Up 2, back 1. So what I'm going to do is take this line, these points, connect them into my line, I guess, like so. Label it down by the arrow that this is the y equals negative 2x plus 4 line. And then I'm going to get the second line on there, which is y equals 3x minus 6. So 3x minus 6 means I have to start at minus 6, which is way down here on the y-axis. And then I have a 3 slope, so I'm going up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. There we go. 1, 2, 3, over 1. 1, 2, 3, over 1. And then I'm going to draw my line through those points, like so. Nice, they cross just like we said they do, they intersect. I'm going to write down by the arrow y equals 3x minus 6 a little more clearly. There we go. And then it is time to label things. So we definitely have a point of intersect where they cross each other. It is this key point right here. So I'm going to label it. It looks like it's at x equals 2, and it's right on the x-axis, so it's at 2, 0. And we would call that the point of intersect. It's where it crosses. So point of intersect. There we go. And I'm going to draw a little arrow right there. Nicely labeled. There we go, point of intersect. The other thing I'm going to label is those y-intercepts. So here's 4. That's a y-intercept. There we go. And the other one crossed at -6 down here. That was where it intercepted the y-axis. So I'm going to write y-intercept. Now usually on a graph, I shorten this and I just say y-int, like that. And most people know what that means. They know it's intercept. But I noticed on, I think it was the last test that we took in class, that a lot of people, when they were writing this out in a sentence, were calling this the y-intercept. And then people were calling this the point of intercept. And I know this is like, they sound similar, but we don't want to mix those up. This is intersect because they cross each other. It's like, think of an intersection on a road. Like we talk about when you learn to drive, like when you're driving down the street and you get to a stoplight because 2 streets are crossing each other, we say, oh, you're at the intersection. Well, that's what this is. It's the intersection of these 2 roads versus these are the intercepts. Okay, so I told you we were going to come back to our front page of our notes. Let's do that now. Now's an appropriate time. So remember we left a little space. You might have left less than me, but that's okay. What I'm going to do is just draw a little arrow here to intercept. This is referring to when a line crosses the x or the y axis. So a line crosses y or x axis. We call it an intercept. An intersect is when you have 2 lines that actually cross each other. So the point where 2 lines cross each other. The point where 2 lines cross each other. I write so big. Here we go. The point where 2 lines cross each other. And I think since I have a little more space here for my notes, what I'm going to do is I'm going to draw a little example. I'm not going to put any numbers. I'm going to make this like little tiny mini graph for each of these just to show what I mean. So kind of sloppy and messy, but kind of getting the point across that the line that crosses the y or the x-axis, so intercepts, like if that's my line, right here and right here is what we would call an intercept. So these points are intercepts. What I'm talking about over here, intersect, is when I have like a line and then I'm going to draw a second line. Maybe it's going, let's make it hit somewhere like this. There we go. This is what I'm talking about when we're talking about intersect, when 2 lines cross each other. And that's the only difference between those 2 wordings. I just want to make sure that when you're talking about intercepts versus intersects in class, that you have it correctly. So small details, but kind of important details for algebra. So I think that's going to wrap up this video. I hope you have a good handle on what's the difference between an intercept and an intersect, and we will talk in class more about that. Thanks for watching, guys. I'll see you later.